So yeah, so we are going to do a problem on this. So on the sliding block. So a block of mass 10 kg rests on a horizontal plane as shown in figure. Find the magnitude of force P required to move the block at the acceleration of 2 meters per second square. Take the coefficient of friction between the block as 0.25. So in this case, we have the P, which has been given as force which has been applied on the block by the block is having a mass of 10 kg. So the P is being applied at the 30-degree incline with the horizontal reference. So now we need to find out what is the P that has to be given when the acceleration is 2 meters per second. So now we'll write the given data. So given data is M is equal to, that is mass of the block is equal to 10 kg, and we have the acceleration is equal to 2 meters per second square. And finally, they said the coefficient of friction between the block and this one is mu is equal to 0.25. So these are the data which has been given. So we need to find P for this condition. Alright, so now we'll find out what are the forces involved in these things in order to find out summation of F. That will be a first step. The first step is to find summation of F. Okay, so in order to do that, we need to list it out all the forces involved in this sliding of a block. So since the P has been applied from the left to right, so the motion direction will be in this direction. So the motion direction takes the preceding over when you're taking about sign convention, so that will be the positive case. So when you have having this, we have W, that is 10 into 9.81 acting off the self weight, and we have a normal reaction. So and this, since we have a motion, so you have a friction force acting on this. So since the P is being inclined, we have two components. So this will be P cos 30 and this will be P sin 30. So it will be divided into two components. So P cos 30 will be aiding into the motion, and P sin 30 will be adding along with the weight, self weight, to sum up with the normal reaction. So we'll see how it is done. So summation of F. So we are going to see only the direction of motion. So it's what are the forces that is involved is P cos 30. So P cos 30 in this case minus, so this is the other force minus FF. That's it in this particular case. So in this case, we expand the FF. So P cos 30 degree minus mu into NR, which will be further expanded as, so NR is going to be minus mu. NR is going to be given as addition of W and the P sin 30. So it will be P sin 30 degree plus 10 into 9.81. So because we are dealing with force, so weight has to be taken. So mass has to be converted into newtons. So we are multiplying with 9.81. So once that is done, so we have putting all the values will get over with us. So what do you have is 0.866 p, that is cos 30 is 0.866 minus 0.2 p sin 30 is 0.5 p plus 98.1. Okay, so further in this particular context, so when you are simplifying this, you'll be getting this 0.741 p minus 24.525. So this is the summation of force which will be arrived. So when you're dealing with this, we have different methods. First we'll deal with the D'Alembert's principle. So I'm going to solve in all the three methods. So see how it is done in all the three methods. So first is D'Alembert principle. So summation of F minus MA equal to 0. So we already got summation of F. The summation of S is nothing but 0.741 P minus 24.525 minus mass into acceleration. The mass is 10 kg into the acceleration is 2 equal to 0. So when further simplifying this, we will be getting P is equal to 60.08 Newton. So simple as that, we got this thing. Now we will try to do it with the work and energy method. So in work and energy method, we have the equation as summation of F into S is equal to half m v square minus u square. So in this case, we don't know what is S, we don't know what is v square and u square. So we will be going with the, even though we are going with this, so it's going to be an indirect method. So substituting the summation of force 0.741p minus 24.525 into S is equal to half into the mass is going to be 10 into v square minus u square. So so we have this particular thing. So now we are getting some direct relation of S in terms of v square minus v square. So we will be left over with 0.741p minus 24.525 S is equal to 10 into v square minus u square. So finally the relation will be in the terms of taking the down 10 to the other side. So it will be, sorry, not 10, this will be 5. So when I take in this, so it will be left over with 0.1482p minus 4.905 S is equal to v square minus u square. So this is the relation we have. Now using this, you can use the equations of motion, like somewhere we can include v square and u square with the a. So we got to use v square is equal to u square plus 2as from the equations of motion. So we are going to use the equation of motion additionally to use to find out the p value, because it's not enough. So we are going to use additionally v square is equal to u square plus 2as. So rearranging this, so v square minus u square is equal to 2as. So bringing that, so when you're substituting the v square minus u square, so you will be left over with substituting the equation which I obtained from the previous case. So it will be 0.1482p minus 4.905 S is equal to, so we have this particular thing, so 2as, so it will be 2, a is going to be 2 and this is s. So s and s gets cancelled, so I left with this thing, so I can arrange this will be 60.08 newtons. So this is second method. Third method is the impulse and momentum method. So similar ways, this is going to be indirect. Again, we are going to use another set of equation to solve this. So summation of f into t is equal to m into v minus u. So I substitute that equation. In this case, it will be again 0.741p minus 24.525 into t is equal to 10 into v minus u. So bringing the simplified version of this equation, you will be getting this as 0.0741p minus 2.4525. So this is t is equal to v minus u. So using this relation, so we are going to solve with the equations of motion. So that will be v is equal to u plus at. So in this case, bringing the v minus u equal to at. So we have v minus u in terms of t as well from this previous expression. So we will express that 0.0741p minus 2.4525 t is equal to, so a is going to be t, so that will be 2t, so t and t gets cancelled. So solving this, we'll also get 60.08 newtons. So this is how we can use three different methods and we can solve it. Okay, so we will see some other problems as we go. So just to show an example of all the three methods that can be used still, whether it's directly solved or indirectly solved. With this, we'll solve this. Okay. Thank you.